In this video, we're going to focus on the domain of square root functions. So let's say if you have the following function, f of x is equal to the square root of x plus 3. What is the domain of this function? The domain represents all of the allowed values of x. Now, you cannot have a negative number inside a square root. It won't give you a real number. So therefore, what's inside of the square root has to be equal to or greater than 0 if it's an even index number. If it's odd, the domain could be anything. So if this was the cube root of x plus 3, x could be anything. It's all real numbers. But if it's even, then there are some restrictions. X plus 3 has to be equal to or greater than 0. So if you solve for x, if you subtract 3 from both sides, x is equal to or greater than negative 3. Now, how can you plot this solution on a number line? So here's negative 3 to the left of 0. Now at negative 3, do we have an open circle or a closed circle? Since x can be greater than or equal to negative 3, there's going to be a closed circle at negative 3. And then we need to shade to the right, since x is greater than or equal to negative 3. Now, how can we represent this solution using interval notation? On the right side, we have positive infinity. So the answer is from negative 3 to infinity. So you can write your domain using interval notation like this. This is the answer. Now, what about this one? Let's say if the radical is in the bottom of a fraction. How would you find the domain for this function? Now, whenever you have a rational function, you can never have a 0 in the denominator. 1 over 0 is undefined. So for this particular problem, we can set what's inside of the radical greater than 0 but not equal to 0. If the radical is on top, set what's inside equal to or greater than 0. If it's on the bottom, it can only be greater than 0 but not equal to it. So if we add 5 to both sides, x is simply greater than 5. So now to plot the solution on a number line, this time we're going to have an open circle instead of a closed circle, and we're going to shade to the right. Now we still have positive infinity on the right side. So the domain for this function is going to be 5 to infinity. Now since we have an open circle, we're going to use the parentheses. In the last example, it was a closed circle, and it's associated with the use of a bracket. So this is the answer, 5 to infinity. Let's try another one. What if we have two radicals? The square root of x plus 2 divided by the square root of x minus 3. What is the domain for this function? Now for the radical on top, we can set it equal to or greater than 0. So if we subtract 2 from both sides, x is equal to or greater than negative 2. Now let's plot the solution for this particular number line. So negative 2 is to the left of 0, and we're going to have a closed circle, and we're going to shade it to the right. Now for the other one, x minus 3, we need to set it just greater than 0 but not equal to 0 since it's on the bottom. So if we add 3 to both sides, x is greater than 3. So if we make a separate number line for this one, 3 is to the right of 0, and it's going to be an open circle instead of a closed circle, but we're still going to shade to the right since it's greater than 3. Now, which number line do we use? The one on top or the one on the bottom? Now you want to find out which region is it true for both. We know that x cannot equal 3. It won't work for the denominator. So the only region where it works for both is the region where it's greater than 3. That's where it's shaded for both. So we're going to have to use this answer, because from 3 to infinity, that works for the radical on top. So once you identify the region that is true for both radicals, that's going to be the domain. So it's from 3 to infinity. Here's another one for you. Let's say if f of x is equal to the square root of x plus 1 minus the square root of x minus 6. Go ahead and find the domain for this function. So let's start with the first radical. So x plus 1 has to be equal to or greater than 0. Now it's not in the bottom of a fraction, so we can include the equal part. So if we subtract both sides by 1, x is equal to or greater than negative 1. For the second one, x minus 6 has to be equal to or greater than 0. And if we add 6 to both sides, x is equal to or greater than 6. So let's graph each one separately. So negative 1 is on the right side, on the left side of 0, 6 is on the right side. So here, we're going to use a closed circle, and we're going to shade to the right. And for this one, same thing. Now, which region is it true for both? From 6 to infinity, it works for this radical and this radical. For this one, x cannot be less than 6. It has to be more than 6. If you plug in 5, it's not going to work. If you plug in 6 or something higher, it's going to work for this radical. So you want to identify the portion or the region that is shaded for both number lines. And both number lines is true from 6 to infinity. Therefore, that's going to be the domain of this function. It's going to start at 6. It includes 6, but it goes to infinity. This domain works for both radicals. Now, let's say if you have a rational function. Let's say 1 over x plus 3. So there's no radicals, which means we don't need any inequalities. The only thing that x cannot be is x can be a number that's going to put a 0 in a denominator or the bottom of the fraction. So for a rational expression like this without any radicals, whatever is in the denominator cannot be 0. So if you solve for x by subtracting 3 from both sides, x cannot equal negative 3. It could be anything else. So if you plot a number line, at negative 3 we're going to have an open circle. But because x could be anything else, it could be anything above negative 3 or below it. All the way to the left we have negative infinity, and all the way to the right we have positive infinity. So for this region of the graph, the domain is going to be negative infinity to negative 3. And then there's a point of discontinuity at negative 3. So we need to write union, and then the second part of the graph, which starts at negative 3 and goes to infinity. So whenever you see an interval notation that looks like this, it's basically saying that x could be anything. It can have any value except negative 3. And so we're going to have a parentheses at negative 3 since it's an open circle. Now let's say if you have a rational function that looks like this. What are the values that x cannot be? If it's in its factored form, you can solve for each factor separately. So x cannot be equal to positive 2, and it can't be equal to negative 1. So to plot the solution on a number line, we're going to have an open circle at negative 1 and positive 2. But x could be anything else in between. So to write the domain, it's going to be negative infinity to negative 1, union negative 1 to 2, union 2 to infinity. This corresponds to the first region. This is for the second region. and this is for the third region. Now let's say if you have a function that contains a radical and it's part of a rational function at the same time. How would you find the domain for this function? So let's start with the top part. We know that the inside of the radical has to be equal to or greater than 0 if the radical is on top, which it is. So let's go ahead and add 1 to both sides. So we know that x has to be equal to or greater than 1. Now for the bottom part, we have a rational expression. We don't have a radical, so we're not going to have an inequality. Instead, x minus 4, it cannot equal 0. It could be anything else, but just not 0. So if we add 4 to both sides, x cannot equal positive 4. So the critical points are 1 and 4. Now at 4, we have an open circle, since x cannot equal 4. But x can equal 1, so we have a closed circle at 1. Now this inequality says that x can equal 1 or it can be greater than 1, which means we need to shade to the right side. But it can't be 4. But it could be anything past 1 except 4. So it goes to infinity. So for the first part of the shaded region, the domain is going to be 1 to 4. Since we have a closed circle at 1, we're going to use a bracket. But we have an open circle at 4, so parentheses. And then union, for the second part of the shaded region, this is going to be 4 to infinity. So this is the answer. So notice that the open circle is part of the shaded region. And thus the 4 is going to be part of the domain in interval notation. If this open circle was over here, we would not even need to worry about it. So I'll give you an example of that. Let's try this one. Now let's say if f of x is the square root of x minus 3 divided by x plus 2. So just like before, we're going to set what's inside the radical equal to or greater than 0. So x has to be greater than positive 3. Now for the bottom, we know it just cannot equal 0. So therefore x cannot be negative 2. So here's 0, here's negative 2, and here's 3. So we have an open circle at negative 2, but a closed circle at 3. And since x is greater than or equal to 3, we need to shade to the right. Now in this case, the open circle is not part of the shaded region. So we don't have to worry about the negative 2, since it's not part of it. So the domain for this particular problem is simply 3 to infinity. X could be anything between 3 and infinity. It can't be less than 3, so we don't have to worry about the negative 2, since it can't be equal to that either. So this is the answer, if the open circle is outside of the shaded region. Now what about this one? Let's say if f of x is equal to the square root of 4 minus x. What is the domain for this particular function? Now we're going to follow the same rules. We're going to set it equal to or greater than 0. So we're going to subtract 4 from both sides. So negative x is equal to or greater than negative 4. Now we need to divide both sides by negative 1. Whenever you multiply or divide by a negative number, the inequality will change direction. So now x is less than or equal to 4. So if we draw a number line, this time the arrow points to the left side. So how can we write the domain using interval notation? All the way to the left we have negative infinity. So it's going to be negative infinity to 4, but 4 is included. So this is the domain. Here's a different example. Well, sort of similar, but a little different. Find the domain for this function. So for the first radical, we know that x minus 3 has to be equal to or greater than 0. And the same is true for the second one. To solve for the first one, we simply need to add 3 to both sides, so x is equal to or greater than positive 3. But for the second one, we need to subtract both sides by 2. So negative x is equal to or greater than negative 2. And if we divide both sides by negative 1, we'll see that x is less than or equal to positive 2. Don't forget to change the direction of the inequality. So now, since we have two separate radicals, let's make two separate number lines. So for the first one, we know that x is equal to or greater than 3, so we need to shade to the right. For the second one, x is less than or equal to 2, so we got to shade to the left. Now we need to find a point where it's true for both. So can we plug in 3? Notice that 3, it works for this function, but it does not work for this one. 2 minus 3 is negative 1, so we can't have a negative inside of this square root. So negative 3 doesn't work. If we plug in any number greater than 3 in this region, let's say 5, 5 won't work in this function. 2 minus 5 is a negative number. Now, if you check this region, let's say if you plug in a number less than 2, let's say 0. 0 is okay for this function. 2 minus 0 is a positive number, but it doesn't work for this function. 0 minus 3 is negative. So if you put the two graphs next to each other, notice that there's no region in which they're shaded. There's no region where both number lines are shaded. Therefore, there's no solution. Let's combine the two graphs. So let's say the first function is in blue and the second one is in yellow. These two regions do not intersect anywhere. So since we don't have a region where we could shade, where it's shaded for both, it's going to be no solution. Let's try another example like this one. Feel free to pause the video for this example. So in this case, for the first one, x plus 4 has to be equal to or greater than 0, and 3 minus x is equal to or greater than 0. So for the first one, x is greater than or equal to negative 4, and for the second, we need to subtract 3 from both sides, and then divide by negative 1, so x is less than or equal to positive 3. Now if we plot the first one, it starts at negative 4, and since it's greater than, we're going to shade to the right. Now for the second one, I'm going to use a different color. Let's use green. It's equal to 3, but it's less than 3, so it's shaded to the left. Now let's combine these two into a single number line, and let's see if there's a region where the shaded regions intersect. So the first one starts at negative 4, and it goes all the way to the right. Now the second one, it starts at 3, and it goes all the way to the left. So notice that both regions are shaded between negative 4 and 3. So that's where it works for both radicals. For example, if I plug in 0, 0 plus 4 is positive. That works. 3 minus 0 works. If I plug in any number between negative 4 and 3, it's going to be okay. If I plug in 3, 3 plus 7 is okay. 3 minus 3 is 0. That works. If I plug in negative 3, negative 3 plus 4 is still positive. 3 minus negative 3, that's the same as 3 plus 3, which is 6. That's positive. Now, if I plug in a number outside of 3, like let's say a number greater than 3, like 4, 3 minus 4 is negative. It doesn't work. So we could put an X there. If I plug in a number less than negative 4, like negative 5, negative 5 plus 4 is negative. It doesn't work. So it only works in this region. Therefore, the domain is going to be from -4 to 3. And it includes both -4 and 3 since we have a closed circle at those 2 points. What would you do if you get a problem that looks like this? What is the domain for this particular function? So if you have a quadratic expression inside a radical, you need to factor. What two numbers multiply to -12 but add to the middle coefficient of 1? This is going to be +4 and -3. 4 times -3 is -12. 4 plus -3 is +1. So to factor this trinomial is simply going to be x plus 4 times x minus 3. Assuming, of course, if the leading coefficient is 1. If it's a number other than 1, it's going to be much harder to factor this trinomial. There's more steps involved. But right now, we can see that our two critical numbers are -4 and 3. Now, in this case, you don't want to say x plus 4 is equal to or greater than 0 and x minus 3 is equal to or greater than 0. Don't do it this way. If you have two critical numbers within a radical, you need to create a number line and check every region. So the way we're going to solve this problem is different from what we've been doing before. The two critical numbers are -4 and +3. If you set x minus 3 equal to 0, x is going to be +3. And if you set x plus 4 equal to 0, when you solve for x, you need to subtract 4 from both sides, so x is going to equal -4. So find the critical numbers first. Now, because this radical is in a numerator, we're going to have a closed circle at -4 and 3. Now let's see where it works though. So if we plug in a number that's larger than 3, are we going to have a positive number or a negative number inside the radical? So let's choose 4. So 4 plus 4, that's 8, that's a positive number. 4 minus 3 is 1, that's positive. Two positive numbers, when multiplied, will give you a positive result. So if we plug in 4, we're going to get a positive number. If we plug in a number between -4 and 3, like 0, 0 plus 4 is positive, 0 minus 3 is negative. A positive and a negative gives you a negative number. Now if we plug in a number less than -4 in the region on the left, let's say -5. -5 plus 4 is a negative number. -5 minus 3 is negative. Two negative numbers, when multiplied, will give you a positive result. So we can't have any negative numbers inside a square root. So it's not going to work for this region, but it's going to work for this region. Therefore, we could shade to the right of 3 and to the left of -4. So now we could write the domain for this problem. On the right, we have positive infinity. On the left, negative infinity. So the answer for the first part, or the first region, is -infinity to -4, and it includes -4. And then union. Now for the second part, the second shaded region, it's going to start at 3 and it ends at infinity. So this is the domain for this particular function. Now let's try another one. Let's say if it's 1 divided by the square root of x squared minus 2x minus 8. What is the domain for this particular function? Now, just like before, we need to factor the expression. So what two numbers multiply to -8 but add to -2? This is going to be -4 and +2. -4 times 2 is -8, but -4 plus 2 is -2. So it's going to be x minus 4 times x plus 2 on the inside. So our critical points are -2 and 4. Now, do we have an open circle or a closed circle at -2 and 4? Now, since the radical is on the bottom, it can't equal 4 negative 2. Otherwise, we will have a 0 in the denominator. So we're going to have an open circle at 4 negative 2. Now, we got to see what regions it's going to work. So let's pick a number that's larger than 4. Let's try 5. 5 minus 4 is positive. 5 plus 2 is positive. So it's going to work on the right side. Now let's pick a number between negative 2 and 4. So if we try 0, 0 minus 4 is negative. 0 plus 2 is positive. A negative and a positive number, when multiplied, will give you a negative result. If we try negative 3 for this region, it's going to be negative 3 minus 4, which is negative. Negative 3 plus 2, which is negative. Two negative numbers, when multiplied, will be positive. So we can only have positive numbers inside the square root. So it works in this region and in this region. So therefore, for the first region, the domain is negative infinity to negative 2, but without the brackets this time. We're going to use parentheses. And then union, for this region, it's going to be 4 to infinity. So that's the answer for this particular problem. So this is going to be the last example for today. Now this problem is already going to be in this factored form. Go ahead and find the domain for this square root function. So it's easy to see that the critical points will be negative 2 and positive 3. So if you set x plus 2 equal to 0, x will equal negative 2. If you set 3 minus x equal to 0, all you need to do is add x to both sides. And then you'll see that 3 is equal to x, which is that number. So now we need to know which region is it going to work. So pick a number to the right of 3. Let's test this region. So if we try 4, 3 minus 4 is a negative number, and 3 plus 2 is a positive number. A negative times a positive is negative. Now if we try 0, 3 minus 0 is positive, and 0 plus 2 is positive. So two positive numbers will create another positive number. Now for the left side, if we try, let's say, negative 3, 3 minus negative 3 is positive, but negative 3 plus 2 is negative. A positive and a negative will give you a negative result. Now we want a positive number. That's the only numbers that's going to work for a square root with an even index number. And since the radical is not in the denominator, it's in the numerator, x can equal negative 2 and 3. So we have closed circles. And it can be anywhere between negative 2 and 3, because we're going to get positive numbers if we plug in any number between those two regions, or between those 2 points. Therefore, the domain is from negative 2 to 3. And that is it for the square root function. Now you know how to find the domain of radical functions. So that's all I got for this video. Thanks for watching it, and have a great day.